going to be going through 7E today from Unit 3 and 4 Methods Cambridge textbook. It is focusing on understanding families of functions and solving literal equations. So this is everything we've already done before. I just put up on the screen the families of the function of mx, which is linear. So it's saying that m is it's all real numbers and they've all got the intercept on the y-axis at 0, but the gradient is just changing. So they are a family. Likewise, another family I could look at is a x to the power of 3. So we have got a cubic function here with an inflection at the moment going through the origin. So the only thing that is changing is my dilation and reflection. So it doesn't matter what number I put there, it's going to be a family of this function. So let's go through some examples of what we'll be doing. So with this question here, we've got the function with a domain of real numbers is sketched with all real numbers. F of x is equal to kx plus 5, where k does not equal 0. So the first thing, what we're thinking here is this is linear because it's a number x. When we're saying find the x-intercept, the first thing I'm going to do for any x-intercept is we always need to make y equals 0. This, so I plug that into my equation. We are solving for x in relation to k. So I need to take away 5 and then I divide by k. So I've got -5 over k. For what values of k is the x-intercept greater than 2? So that means my x's will be 2, and we need to think about what inequality sign we're going to put in. And I'm going to put this because I want 2 to be less than what is on my right-hand side. So 2 is less than -5 over k. Now I just need to get k by itself. So because it's a fraction, I'll times both sides by k. It cancels out on my right-hand side. And then I divide by 2 to get k by itself. Just remember, if I was timesing or dividing by a negative, my inequality sign would switch. Next, if I'm finding the inverse, so I'm starting off with my kx plus 5, and because we're looking at inverse, I just need to switch my x and y. So that means it's going to be x is equal to ky plus 5. I will then take away 5, and I will divide by k. When we're finding the point of intersection of y equals f of x and y equals x, so when it's intersecting on the y equals x, it means it's going to be intersecting with my inverse that I have here, because we know the inverse and the function always meets on the mirror line, y equals x. So all I'm going to do is write my equation down. Because I know y is equal to x, this is my y value. I'm plugging in x. So the next part is I need to get x by itself. So I will take away kx. So I've got x, take away kx equals 5. Next is I need to factor out the x. So if I factor out the x, I've got 1 take away k is equal to 5. Now from this, I'm going to get x by itself by dividing by 1 minus k. So this is where I can take away those brackets because I don't need it. Find the equation of the line perpendicular to y equals f of x at 0 and 5. So the first thing we need to be thinking about for perpendicular is one gradient times the other equals -1. So we would have learned, let's get our pen. I would have gone over that we flip our gradient. So make sure it's a fraction. And then we look at the sign. One has to be positive, one has to be negative. The easiest way to think about that equation. So in this case here, my gradient is going to be kx. So k. So if I wanted to write k in terms of the perpendicular gradient, I flip it, it becomes 1 over k, and I put a negative sign. The next is we are going to look at our formula that we're using, which is y take away y1 is equal to m in brackets x take away x1. So we know our x value, we know our y value, and we know our m. So we're just plugging in those values. Next is we just need to simplify. Well, we know x take away 0 is just x, so it's really x times negative 1 over k, and we're adding the 5 to both sides. Let's look at this next question. Consider the function with a domain of all real numbers is sketched with all real numbers. F of x is equal to x squared plus ax, where a is all real numbers. So again, with our x-intercepts, we know x-intercepts means y equals 0, so I make f of x equals 0. The next, there's multiple formulas we can use for x-intercepts. In this case here, my two terms have x, so I will factor x out. Now, if one of those is equal to 0, the whole thing is. So if x is 0, my whole thing is 0. If x is negative a, my whole expression here is 0. So I've got my two answers. When x is 0, y is 0. When x is negative a, y is 0. Find the vertex. This is where we need to make sure we know all our formulas. So a vertex would be x equals negative b over 2a. Remember, this comes from the quadratic formula at the very start. Then from this, we need to know what is our b value, and our b value is a. Our a value is 1. So if I just put that in, it then turns into negative a over 2. Because I'm wanting a coordinate, I substitute this into my equation. If I substitute it in, then I've got negative a over 2 squared. So remember, that will be negative a times negative a, so that will be a positive a squared, and 2 squared is 4. Likewise, on the second term, a times negative a is negative a squared, and then just 2. When we're adding fractions, you need to make sure they are the same. So I'm timesing my numerator by 2 and my denominator by 2 to make sure that they are the same size. That gives me negative 2a squared over 4. Now that they are the same, I am able to use my operations. So that will be a squared plus negative 2a squared gives me negative a squared over 4. I've got my x value, I've got my y value, I can write it as a coordinate. Then it says find the points of intersection of y equals 2x in terms of a. So that means because we have our equation in y equals 4 and we have this equation in y equals, we can use substitution. So we substitute 2x in as y, and now we just need to solve it. So to start off with, I'll get 2x to the other side, so it equals 0. The next part I'm going to do is I can see that ax and 2x both have x. So I really need to know what my b is in my quadratic. So I will factor that x out. So now I can see my b is a minus 2. Okay, so now from this, I can see that both my terms have x. So I'm going to factor x out, and I've got x over here, and I'm just going to simplify what's left in my bracket. So that will be x plus a minus 2. So if one of those is equal to 0, the whole thing's 0. So that means x can be 0 and y will be 0. And here, Now, the second part I can do is looking at how do I make this 0? Well, x must be 2 minus a, and then that will equal 0. Let's double check our coordinates because this is just in terms of this simultaneous equation, but I haven't plugged it back in. So my first equation would be, I know I've got x is 0, so I put it into here. 2 times 0 is 0. That's my first answer. The second answer, I know I've got x is 2 minus a, comma. So I plug that into my x. 2 times 2 is 4, and 2 times negative a is negative 2a. So that is my answer there. Let's continue. Find the values of a. Is there one intersection? So straight away with one intersection, the first thing I need to do is use my discriminant. So we know if we're looking for one solution, it means this is going to be equal to 0. I substitute what my B is, what my A is, and what my C is. And that's the reason why I wanted it in that form that I started off with, because it makes it easier. So in this case here, we are using this rule here. I'll just box it. Okay. So that means we've got our A, which is 1, and our B, which is A minus 2, and our C, which is 0. So when I do the next step, if C is 0, this whole thing here for AC will be nothing. So I ignore that and just go to B. B is A minus 2, so I put A minus 2 in brackets squared. Now, to make this 0, A just needs to be 2. So the next step is find the values of A. Is there two intersections? So again, I'm using the same rule, but it needs to be greater than 0. So 0 is less than B squared minus 4AC. Now I substitute everything in like I did before, so it's really going to the same step. Now all this is saying is A cannot equal 2 because I could square it both and get the squared gone, and then I'll plus 2 to the other side. So it's just A cannot equal 2. Let's move on. We are going to be doing some transformations. So the graph of y equals x squared is transformed to y equals f, x minus h in brackets plus k. Find h and k if the graph passes through 2, 5 and has a vertex of 1 and 2. So the first thing is I'm going to write down my basic equation because I know we're talking about vertex and we're talking about a quadratic. So I've got a in brackets x minus h squared. The second part is I'm going to substitute my values. I forgot to put in my k here. So we know based on what we have, our vertex is 1 and 2, so h is going to be 1 and our k will be 2. From there, I am now going to substitute my 1 point in, 2 and 5, and that is to get only the variable a by itself so I can solve. Now I just need to slowly solve this. 2 take away 1 is 1. 1 squared is 1. 1 times a is a. So I'm left with 5 equals a plus 2. The next part is we need to get a by itself. To get a by itself, the first thing I do is take away 2 and I get 3. Then if I'm sketching the transformation, I first need to put the a into my equation. Now we always start off with Dr. T. So the first thing I'm going to think about here is the 3 in front is referring to the push away or the stretch away from the x-axis. So that's the first part. I've got no reflection, so I ignore that. And then I look at the translation, the horizontal and vertical shift. So horizontal is always looking at what is going on here in the brackets. So x must be 1 to make that 0. So it's a shift of 1 unit in the positive direction. Then we've got the vertical shift. The vertical shift is always what's on the outside, and it's +2. So it's 2 units push, translating up in the positive direction of the vertical shift. Okay. Next, we have our solving equations, and this is literal equations. So the first step that we are going to do is look at 3e to the power of x, take away 5 equals 0. Now with this, it's exactly what we've always done, is we plus 5 and then we divide by 3. We are getting the e exponent by itself. Now I've got it by itself, and we're talking about exponents. The opposite of exponents is logs. So we're going to connect it into a log. Now I could say log base e, or I could write it as ln. ln 5 over 3 is equal to our exponent x. Likewise with ln x minus 3, we know ln is base e. So to change it to an exponent, I will be e to the power of 1 equals x minus 3. Now, anything to the power of 1 means it stays the same. So then I just plus 3. The last part we are going to go through is understanding a bit more about transformations. So we've got xy is going to be shifted to the image of 2x minus 1, 3y plus 4. So we are going to first express x and y in terms of the image of x and the image of y. So we know that this is the image, and we also know that this is the image of y. So I'm just going to turn them into 2 equations. The first equation I've got is the image of x, but we're wanting to find it in terms of x being the subject. So this is where we just add 1 and we divide by 2. I do the same with y. To get y by itself, I take away 4, I divide by 3. So now we have to find the image of the curve y equals x squared under t. So this is where we need to know that this is going to be on my left-hand side and this is going to be on my right-hand side. Because normally, a normal equation, we would have y is equal to x squared. So what is happening with my y? So I'm going to have to delete that just so I can put the next part on. What's happening to y is on my left-hand side, and what's happening to my x goes into y equals x squared. So we need to make sure we got that squared part on the outside because the transformations of x happens inside there. Likewise, now I need to get the image of y by itself. So that means I'm going to times by 3, and then I'm going to add 4. Now, if I wanted to get rid of dividing by 2, I can get rid of it and make it 3 over 4 in brackets image of x plus 1 squared plus 4. How I would do that? If I rewrite this slightly, inside my bracket, I could factor out a half to get rid of that. But because it's squared, I would have factored a half out of my other one as well. So that means I factored out a half times a half, which is a quarter. So knowing that I factored out a quarter, 1/4 times 3 is 3/4, which is why I've got 3/4 on the outside. Hooray. Now erase this. I've got space. Okay. Next part is we are finding the point on the original curve that maps to 1 and 7. So this is where we need to use our equations that we found here. We know what our image is going to be 1 and 7. So I plug in those values and I solve. And then I get my 2 points, x equals to 1, and sorry, that should be y is equal to 1. So then I get my point 1 and 1.